All right, welcome everyone. Let's start the presentation. So we're going to do Apache HBase State of the Union. Before we start, my name is Enes. This is my email if you want to reach out with questions or you have a Jira that we should take a look at, you can ping me there. I'm a committer and PMC member of HBase, Phoenix, and Hadoop. And I'm working on the HBase and Phoenix team at Hortonworks. All right. For the presentation, we're going to cover the first versions and compatibility story between recent releases. I know that there is a lot of releases going on, so hopefully the presentation will give you an idea of what to expect and what release contains what. And then we will continue more focused look at the recent releases, especially 1.1, 1.2, and 1.3, which is coming very shortly. Then we will take a look at new developments going on. We will cover some of the features that are, some are committed already, some are not committed. They are halfway done or they are in the works. And some are planned for 2.0 release, so we're going to cover some of those. And then we will take a look at 2.0 release plans and what to expect from that. Okay? So versions. As you guys may have already know, starting with the 1.0 release, this is last year, we set, as a project, we wanted to work towards semantic versioning because of our, our releases starting from 90x kind of thing was always shooting for the 1.0 release lines. After we achieved that, we want to basically give the users a basic expectation of what to expect if they are upgrading a specific release, from a specific release to another specific release. So semantic versioning is a very, very straightforward proposal. What it says is that the releases have to be broken down into a major minor patch. So 1.1.2, 1.1.3, and so on. You guys are already familiar with this. And then there can be also release identifiers with that. So for example, it can be 2.00-alpha, 2.00-beta, something like that, right? So again, we've started doing the semantic versioning starting with 1.0. And we've already done 10 releases so far with the semantic versioning scheme. So we have 10 different releases of the 1.x.y kind of scheme, and more is definitely on the way. We will cover that as well. The release notes contain like some compatibility reports for source and binary compatibility at the Java layer, so that you can, if you are very interested in taking a look at what is the difference between 1.2 versus 1.3, what is the difference between 1.0 to 1.3, for example, you can take a look at the release notes and check the actual compatibility report being generated automatically from the tools to check whether what kind of source compatibility and binary compatibility has changed or not. Patch upgrades do not have any new features. We are trying to follow this as much as possible, and we are trying to make patch upgrades as much as a drop-in replacement as possible. So this is not super straightforward because HBase is a very big project with a very large surface area to cover, but we are doing our best to make it so that upgrading a patch version, which means that if you're upgrading from 1.1.1 to 1.1.3, it should be a drop-in replacement. There should not be anything changed, and it should only be bug fixes. We are trying to make this reality more and more. We are trying to make this more and more reality, and then we are trying to make it so that every patch version is more and more stable within the same minor version. And another promise for the semantic versioning is that minor versions are compatible, but the compatibility is, we will cover, is not a yes and no decision. So to be or not to be compatible. So unfortunately, everybody asks, especially users ask, or our clients ask, whether 1.1.x is compatible with 0.98, or 1.1.2 is compatible with 1.1. Something. So unfortunately, compatibility is not a simple yes and no. Compatibility has many dimensions, and then we're going to cover some of these dimensions. And the dimensions for compatibility, especially related to the application and the upgrades, are, for example, there is the source compatibility implications, there's binary compatibility implications, wire compatibility, command line and tooling, and dependencies, and other dimensions. Good thing is that we've started marking the client application level interfaces with this annotation. So if you, I don't know whether it's readable or not, but there's a specific annotation that we are following from the Hadoop, which is the interface audience.public, private, or limited private. So what it means is that if an class or method is marked as a public interface, then it means that it has the highest level of standards for compatibility, and this is our basically HBase's public API. If it's marked as limited private and limited private to coprocessors, then it means that it is a limited private interface only to be exposed to coprocessors, and it is the next level of promises that HBase community tries to give you. And if an interface is marked private, then there is no guarantees whatsoever from the source and binary or any other compatibility dimensions that we provide. If you're consuming such an API, for example, in your code, upgrading a patch version just can break you. And we'll definitely come to the other topics. If you want to read more, there's some documentation available in the book. You can check that. As I was talking, the compatibility dimensions is not yes and no. It is basically different dimensions. And within the major, minor, and patch versions, we are trying to give different promises so that the upgrading is as easy as possible, and the semantics of what to expect is clear. The short version of this is that within the major versions, we don't have to keep any compatibility whatsoever, which means that HBase 2.0, the HBase community can decide to not have any compatibility between 1.x and 2.x. It doesn't mean that we will break it. It just means that we are not binding ourselves with the implications. So there's a star, for example, for the file format compatibility, for example. What it means is that if, for example, in a later HBase 3.0 release, HBase 4.0 release, for example, we will, if, for example, file formats change or whatever, you would still have to be able to migrate your data to the new formats. That's the only guarantee that we're going to have. Within the on the rightmost column, within the patch versions, as you can see, all the compatibility dimensions is marked as marked. So again, this is the highest level of promises that we are giving, which means that we're just telling that if you are upgrading a patch version, everything is expected to work. Nothing is expected to break. If you're upgrading within a minor version, then some things are expected to be compatible. Some things are not expected to be compatible. So minor version means that if you're upgrading from 1.1 to 1.3, for example, client-side wire compatibility will always be there. What it means is that if you have wire compatibility is at the RPC level, right? If you have a 1.1 client talking to a 1.3 server, it will always work, right? Or vice versa. If you have a 1.3 client talking to a 1.1 server, it has to always work, right? Server-to-server compatibility is the same thing. This comes into effect when you're doing a rolling upgrade, because rolling upgrade, while the rolling upgrade is going on, some of your servers will be 1.1, for example. Some of your upgraded servers will be 1.2, right? So it is always expected to work when you're doing a minor version upgrade, right? File format compatibility is the same thing. The thing that's not promised, for example, within the minor version is client-level binary compatibility. Because of the Java semantics, for example, you cannot compile your code against 1.1 and then hot swap the jars of HBase and run it with 1.3. So this is because of the hardness of having binary compatibility at the Java layer. So what we are promising is that we will have the source compatibility between minor versions. So it means that your source code does not have to change for your client application for 1.1 to 1.3, but you may have to recompile your code. As long as you are running with the code that you have compiled with, you're OK. All right? And the last thing I want to touch on is the server-side limited API compatibility. Within minor versions, some of the coprocessor APIs are also changing. So you may, if you're using super advanced APIs within the coprocessor framework, you may have to be careful, and then you may have to evaluate the upgrade in that respect. All right? All right, let's talk about releases. So this is the last year and this year, the state of the repository and the recent releases. As you can see, the topmost line is the master code line, and master is now scheduled for 2.0, and the release version is 2.0 snapshot. The branch 1 has been forked some time ago for releasing the 1.0 release lines, and we have, as you can see, 5 different release lines going on at the same time. We have at the very bottom layer, we have the 98 releases going on. There has been 20 releases of that branch so far, and it's going to continue for some more time. Branch 1.0, we've done 3 releases of that. We've done 1.0, 1.0.0, and we've done 1.0.1, 1.0.2, 1.0.3. Branch 1.1, we have done 5 releases so far. Branch 1.2, we have done 3 releases. 1.3, the release candidate is in the works. I think it will hit very soon, maybe this week or next week. But the thing to point out is that, like, if you're consuming the Apache artifacts, you definitely have a lot of choices. And then within, if you are, for example, in 1.1, you should always upgrade your patch version as soon as possible. All right? All the releases come with the what we call release notes. The release managers usually go over all the JIRAs for you. Typically, a release will contain 300, 400 different JIRAs if it's a minor version. If it's a patch version, it will contain 100 or so JIRAs. Typically, the release managers go over these JIRAs and then give you a summary with the release notes and the release announcements. So I encourage you to check out those release notes if possible. They are posted in the user mailing list and as well as the developer mailing list. We will quickly go over these release notes for 1.1, 1.2, and 1.3, right? So 1.1, it comes with the asynchronous RPC client, which is changing the RPC client underlying, and it uses less threads and everything. It has simple RPC throttling, compaction controls like throttles for the compactions and everything. A bunch of scan improvements are there in the 1.1 releases, like the scanner hot beating and the batching and the chopping up the large rows into different pieces is definitely there. Procedure v2, there's a lot of improvements there in 1.1 release line, so that's why 1.1 is very important for master stability. There's some interfaces for coprocessors that are new, like the region interface. Per column family flush makes sure that if you have 2 column families and one is like super big, the other one is super small, you can do only flush 1 column family while leaving the other column family in the memory. There's wall on SSDs, block cache. block cache in memcached, this is another thing, and region replica enhancements. This is there in the 1.1 releases. 1.2, we started certifying JDK 8. Previous releases also can run with JDK 8, but it wasn't tested to the extent that 1.2 is tested with. Also, 261, Hadoop 261 and 271 is now supported. Per column family time ranges for scan is a scan improvement that's new. The reloading of the dynamic reloading of the configuration for the region servers is there, so that you can send a SIG-hop signal to the region server. It will automatically reload the HBase site configuration. Region location methods added to the Thrift2 proxy. This is just a small improvement. Table level sync. This is I think very relevant. If you, for example, have replication and then somehow the replication is broken due to whatever, you can use this new tool to sync up your two tables without doing a full table copy over at the other cluster, because this will make sure that only the changed rows are sent over to the other side. And there's also a bunch of client-side metrics coming from the JMX. Okay, and 1.3 release line is again is coming very shortly. It has the data compactions. We will take a deeper look at it at a later time. There is also Maven archetype for HBase client applications, so you can start a new HBase client application by using Maven archetypes. Throughput controller for flashes is there. A new control delay RPC scheduler is there. Buckload hfiler application is also a very popular feature. For example, this is to do with buckloaded files. If you, before 1.3, if you buckload a file in one cluster, even if you have replication set up, the buckloaded files will not be replicated on the other cluster, because the buckload bypasses the whole write-ahead log and the write pipeline. So with this change, for example, we will also replicate the buckloaded files to the other cluster using this CP-like mechanism. Procedure v2, so a bunch of improvements. Multi-wall, so a bunch of improvements. And metrics, definitely, so a bunch of those as well in terms of the speed and everything. Reduced memory allocation in the RPC layer and overall is there, and some region location optimizations in the HBase client itself. So this is 1.3. So one of the most important questions that from users is like, how do I choose a particular release? How would I know whether to pick 1.0? How would I know whether to pick 1.2, for example, right? So for this, I try to give a short summary. You can, if you're interested in a specific feature, for example, like HBase hfiler replication from backloaded data, for example, you have to go with the 1.3 release lines if you're consuming the Apache artifacts. If you're not, you can talk to your vendor, definitely. But if you're on the Apache release lines, for example, the 98 releases are still continuing frequently. The release manager, Andrew, said that he will likely continue the monthly release schedule likely to the end of this year. So if you're on that, you can go to 98.20. Probably it will go to 24 or something like that. 1.0 release lines is end of line. So if you're on that, please go to 1.1 at least. The last release was 1.1.2, which I did like maybe a couple of months ago. But yeah, if you're on that, move to 1.1. Both 1.1 and 1.2 are pretty stable releases. If you are starting from scratch, you should definitely go to 1.2 or 1.3. But if you're stuck on 1.1, it's also fine. 1.1 is pretty stable in terms of what it contains and everything. If you don't need the new features that's coming in 1.2 or 1.3, you can stick with it. 1.3, again, is coming very shortly. And the good thing about all of this we've talked about is that moving between different minor versions is relatively easy now. But if you if you are on 1.1, it should be relatively easy to go to 1.3, for example. And you can always go from 1.0 to 1.5, for example, when it's released, without going through all the intermediate steps. All right, so we're going to cover some new developments in the works. And if you guys have any questions on any of those, we can do it at the Q&A session. So the first thing I want to talk about is the new compaction policies for time series. This is a relatively important topic if you have time series data and your queries are always coming with time ranges. So we have two new compaction policies. The first compaction policy is called the FIFO compaction policy. It is the most simplistic compaction policy that you can ever think of. There's no compaction. So if you enable FIFO compaction policy, there won't be any compaction at all. So why would you want that? Is that if you have a very short TTL, for example, let's say you have a TTL of 6 hours. And the data is like a queue, it's like a moving window. You write, you ingest, and after 6 hours, you delete the data automatically with TTL. So in that kind of case, and your queries are always coming and reading the last 5 minutes, reading the last 10 minutes, or reading the last hour or so, then you don't want any compaction, because compaction is just extra work for you because you already have a moving window. So you can use this compaction policy if you have such a use case. Obviously, since there's no compaction, you can end up with 100 files in a single store. So you have to be careful. Data compaction is the second one. This is coming from Flurry. This can give you a very dramatic reduction on the I/O, and because of the fact that the compactions are bounded by the time windows, and the files are compacted together with the other files that are in the same window. So what happens is that if you have time range filters with scans, then your scans will see a lot less files, and then but you can still get away without doing compactions. So the next set of graphs actually illustrates this perfectly. I've got this from the Spotify blog. So on the left side, there is the regular compaction policy. So going from left to right, the time increases, and these are the green ones are the H files, and the time ranges that these H files has. So the first H file contains the data for all the times. And let's say the bottom ones contain only the recent data. But if you're doing a scan, for example, in that range, in the yellow box, you have to read all these files. You have to do a seek in all of these files together. But with a data compaction policy, since you will have different time windows, which are exponentially growing back in time, and then you're going to compact the files together where their time ranges align, then you would have something like this. The green ones will have still the time ranges. And if you want to do the same query, reading the same time window, you will only hit 3 files instead of 10 different files. So if you have a time series use case, definitely take a look at this. There's a presentation about it as well in the HBaseCon. You can check that. The other important thing is the Spark integration. This is natively from Spark to HBase integration. The RRD work has been done some time ago, And now there's new work that has been going on, which adds the data frame, the data set, and the Spark SQL support. It can do partition pruning. It can do column pruning. Data locality is there. So the Spark executors talk to the local region server and everything. And also the some form of predicate pushdown is there. So for example, it can push down the column selections and everything, and some simple column filters like this column should be greater than 5, this column should be less than this, kind of thing. Here's an example of the Spark integration. We won't go over any details of that. But as you can see, you can declare a table from Spark as a data frame, and then you can use Spark SQL to query the data by just treating this as a data frame. All right. So some new improvements in the performance side. There is some work going on for doing more and more asynchronous programming. As we've already talked, 1.1 contains an asynchronous RPC client. This is already there in branch 1 and in 1.1, but this is disabled by default. But in HBase 2.0, this is enabled by default, so you would get this automatically. There's also work going on for doing an asynchronous client itself. So everybody probably is familiar with the asynchronous HBase client that the OpenTSDB guys have developed so far. This is a different implementation for the asynchronous client, and this will be within the HBase code base itself. It is based on Netty's libraries to do the asynchronous programming. There's also a asynchronous write-ahead log writer, which is at the HDFS level for our write-ahead log implementation. So these hopefully will give much more performance from the client side. There's also other improvements in the internals of HBase. So there is the what's called the row lock, where the row lock guarantees that the write transactions are conflicting and everything. Without going into too much details, the changes there is that the row locks are now read-write locks instead of just exclusive locks. This definitely helps with the regular puts and everything. That is the standard use case for HBase, I would say. And also the write path is reordered. So the core write path where we would do the memstore, then the write-ahead log, then sync, and everything got changed. And now we are doing the write-ahead log first, then doing the memstore updates, which is much more performant and much more batchable in the sense that you would definitely see some performance improvement at the right side. Continuing on, there is some RPC scheduling improvements. So if you guys are interested in that area, definitely check the new discussions going on. There's new RPC schedulers. There's like short padding of the RPC and everything from the reader threads. If you're interested, go check that. Replication is now seeing some love over the 2.0 time frame. There's an initiative going on. It's called Replication 2.0. So a couple of changes is like the replication state is being moved away from Zookeeper into a different table in HBase. Also, the replication requests are routed through the master. And that's one thing. Also, there is like more performance-related things related to the replication, like pipelining the replication requests and everything. So also, there is a new replication interface that has been there for some time. But if you guys are not familiar with it, you can also check that out. Today, you can plug into the HBase's replication mechanism and then replicate to a different data store yourself. Other interest area is the garbage collection and our continuous struggle with the Java and the amount of garbage being generated. In some cases, we have seen in some of our clients that a single region server can generate 5 gigabytes per second garbage. Like 5 gigabytes per second, we can completely saturate the memory bandwidth by just creating garbage from the region servers. So there's always work going on to reduce the amount of garbage being generated. This helps a lot with the tail latencies and also helps with the overall performance because of the fact that less garbage being generated means less number of stop-the-world pauses, which means that better performance and a lot stable latencies that you would see. And there's also work going on for the C++ client. There is now, I think this time we will end up with a working C++ client, hopefully in the 2.0 timeframe. There is some code today that actually works and can talk to region servers and everything. Now we are discussing the next steps for how to do the API correctly in the C++ sense and how to basically do asynchronous client versus synchronous client and this and that. Another interesting development is backups and restores. So HBase did not have backup as a concept. We always had the snapshots and exporting of the snapshots and everything. So the backup concept would introduce specific commands for doing a backup of a table set. So you would say, my table set foo is table A, B, C, D, E. I will do a full backup of this table set every week. I will do an incremental backup of this table set every day. And then the full table backup is based on the snapshots and exporting of the snapshot to a different place, like S3, for example. And the incremental backups are based on the concept of the write-ahead logs. So we are keeping track of the write-ahead logs from your last full backup, and then we're gonna ship these write-ahead logs to the backup location. If you want to restore, we are gonna we're gonna restore the snapshots and then replay the write-ahead logs on top of these snapshots so that you would have working end-to-end backup and restore commands. All right, moving on. Off-heaping. So this is another major work that is connected to both the performance side and also the garbage collection side. So as you guys are familiar with the bucket cache is our off-heap block cache implementation, which is very crucial if you have 200 gigabytes of memory. It is your only option to use that kind of memory with the region server. But one thing that we always had this struggle with the bucket cache is that every time a block from the bucket cache, which is in off-heap space, have to be read, that whole block, which is, let's say, 32 kilobytes in size, have to be copied to the Java heap space, and then the operations will be done. But with this new work in 2.0, the read path would be completely working from the off-heap cache. The key values are completely backed by the off-heap data structures, so that there's no copying from the off-heap to the on-heap back and forth, back and forth. This helps a lot with the performance. I think some initial numbers, so like 20% or so improvement in the random gets speeds, as well as this reduces the garbage being generated by a lot if you're using bucket cache. The write pad is also, there's a bunch of improvements for using the off-heap space for the write pad as well. So there is now work going on for the second item, the in-memory flashes and compactions. So for example, the mem store can do an in-memory flush from the heap space into the off-heap space. And then we don't have to do a flush to disk as soon as possible. We can hold on to that flush to disk as much as possible, which means that we can do feather flushes. Feather flushes means that instead of flushing 30 megabyte files, we're going to flush 200 megabyte files. Why is this important? Is that if you are doing fatter flushes, it means that you are doing less compactions. It means that you're doing less I/O, which is overall very good for you. And the last topic is assignment manager and the master. In 2.0, this is definitely getting some attention. So the assignment process itself is being rewritten on top of the procedure v2 framework. And hopefully, there will be a lot stability improvements in this new work. All right, quickly talk about the 2.0, what to expect. So the target, so Matteo is the release manager for 2.0. We're targeting for end of year for the release. We'll see. One thing that we've talked about before is that the singularity release, where HBase went from 94 into 96, this actually hurt the users a lot, and we've actually learned from our mistakes. It was a necessary evil that we had to do because we had to move into the protobuf-based RPCs. So this time around, there is no such change at the RPC layer. So we are trying to make the 2.0 rolling upgradable from 1.x releases. So if we can do that, which we are trying to do, then it means that you can do a rolling upgrade between, let's say, 1.3 to 2.0, and your availability from your applications won't be affected, as well as like you can actually do it in a much more safer manner. It will be probably JDK 8 only. If you're not using it, start using it immediately. I think JDK 8 is so much better. It may work with Hadoop 3. We'll see the Hadoop 3's plans. Assignment and the big data layout changes are the big drivers for this. So assignment we've talked about is changing, and the data layout is some of the data layout changes is needed if you have 1 million regions, for example. If you're at the Yahoo scale, you may need that. So those layout changes may be coming in 2.0. So how to prepare? 2.0 contains some API cleanup. Some of the protobuf and Guava has been leaked into our API. Like if you're using HBase admin or HTable, you may notice that some of the APIs are using protobuf, for example, exposing protobuf. So we are plugging those holes and replacing those with Java level objects because we don't want to expose protobuf objects directly. So as you guys may have known, the H connection, HTable, HBase admin, and the previous 1.x releases, these interfaces have been deprecated in favor of the new ones. So the 2.0 will be removing some of these APIs. So you cannot, for example, use H connection because H connection is not there. You have to use the connection object. There's a good couple of slide decks that you can check. Again, it will be JDK 8 only. Hopefully, 1.x clients can talk to 2.0 clusters as well. This is the goal. We may end up with having something like some DDL operations or admin operations, like, for example, setting up replication from 1.x clients to 2.x clusters may not work. But if you're doing MapReduce or if you're doing just puts and gets, it should work. All right, so this is the last slide. So there is definitely some other HBase talks you should check out. There's the Omid talk today after this session. There is the Hive HBase Metastore, which is interesting. Hive is using HBase as a metastore. You can check that. At 5 p.m., there's a joint talk from Tanvir and myself about operating and supporting HBase clusters. You can check that. And tomorrow, there's a couple of talks as well. There's the Yahoo talk. There's the Cask talk. There's a Phoenix talk, if you guys are interested. And at 5 p.m., there's a Birds of Feather session tomorrow. So you, feel free to come up if you have questions. or if you want to talk about HBase. All right, thanks for listening.